In this video we're going to look at what a function is. So a function is like a graph that doesn't go back on itself. So for example, we know y equals x squared looks like this. So here you've got a graph that doesn't go back on itself. It never turns around. It's always moving to the right. Whereas if you look at this graph, it goes back on itself. For example, you're always moving to the right, you're always moving to the right, you're always moving to the right. When you get to this stage, you're actually turning around and moving to the left. I'm moving to the left, I'm moving to the left, and now I'm moving to the right, I'm moving to the right. So here is, you've got a graph that turns back on itself. So this is not a function. Whereas this graph here is a function because it's always moving to the right. So when you see this, you can actually replace it with this. You can actually discard the y and just replace it with this. So when I use this notation, I'm trying to communicate to you that whichever graph you're looking at here, you're looking at a graph that doesn't turn back on itself. Whereas let's just imagine, it's not true, but let's just imagine this is x to the power 3 take away x squared. That will give you this graph. It's not true, but let's just imagine it is. Here I don't have the right to use this notation. I can't do this, x squared minus, because if I were to use this notation, I'm trying to communicate to you that whatever I'm looking at here, you're looking at a graph that doesn't go back on itself. But here you've got a graph that turns back on itself, so I can't use this notation. Whereas over here, I do have the right to use this, f of x equals x squared. So here I'm trying to communicate to you that I've got a function and it doesn't go back on itself. I do have the right to leave it as this. This is okay. But if I use this notation, I'm giving you an extra piece of information. I'm saying that whatever you're looking at here, it won't go back on itself. Whereas over here, I have to use this only. I can't use f of x. I can't use this. I have to use this. This is okay. I'm trying to communicate to you that we've got a graph. It might go back on itself, it might not. You just don't know. But over here, the minute I use this f of x thing, you know that you're looking at a graph that doesn't go back on itself. So for example, look at this one here. It's a graph this graph is always moving to the right. If you draw a vertical line, it's always moving. There's only one point. Whereas if you look at this thing here, it's a graph that goes back on itself. If I draw a vertical line here, you can see that it crosses so many points here. If I draw a vertical line here, you can see that it crosses here, it crosses here, it crosses here. The minute it turns back on itself, it crosses more than one place. Whereas over here, if you draw a vertical line, only one single place, one single place, one single place. Here, draw a vertical line, you've got 1, 2 places. So this is not a function. This is a function. This is a function. This is not a function. Another example, this here is a function. This here is a function. I can leave this graph as being y equals this, or I can actually communicate to you that, oh, you've got a function at hand. You've got a function at hand here. So I do have the right to leave it as this, or I can use this. If I use this, it's giving you an extra piece of information. You're looking at a graph that doesn't go back on itself. In the future, when you're older, you will see a graph of this form. You see, this is not a function. You draw a vertical line here. So it crosses here, it crosses here. You draw a vertical line here, it crosses 3 places. 1, 2, 3. Whereas if you look at this here, a vertical line, only 1. Vertical line, only 1. Vertical line, only 1. Vertical line, only 1, and so on. So this is a function. So here's another example of a function. So this is a graph that doesn't go back on itself. It's always moving to the right. If you draw a vertical line, there's only 1 point. Vertical line, only 1 point. So this here we know is a function. So I do have the right to replace this with f of x equals this. So this is a function now. Another way of thinking about a function is, there are lots of ways of thinking about a function. When someone gives you a function, another way of thinking about it is like you've got a machine. Here, if you put in the number 3 into this machine, so what this machine is doing this, 2x plus 1. So think of this as like being a machine. You put a 3 into the machine, So you put a 3 into here. So now you put a 3 into the x. So it's 2 times 3, which is 6, plus 1, it's 7. So it spits out the number 7. So I do have the right to do this. F of 3 equals 7. So this whole block here equals 7. So this is just a notation. It means that whatever number here you've got, you put it into the machine, which would then be 3 here. So it would be 2 times 3 plus 1, and so on. So hang on, let me give you another example. So here you've got a machine. If you put in the number 0 into the machine, what will it spit out? So basically I'm saying this: put 0 into the machine. Well, when I put 0 into the machine, I actually put 0 into here. So that means I've got to put 0 into this x here. 2 times 0 would be 0 plus 1. So we'll spit out the number 1. So in this case, this whole thing here, when you put 0 into the machine, it will spit out the number 1. Another example is if I put in, let's say, a -4 into the machine. So when I put -4 into the machine, I'm actually looking at this, f of -4. So whatever's here is what you put into the machine. So I'm putting -4 into the machine. That means I've got to put -4 into this x here. So it would be 2 times -4. That would be -8 plus 1. That would be a -7. So if I put in a -4 into the machine, it will spit out the number -7. So this thing here would be -7. So when I put a -4 into the machine, it will spit out the number -7. So in the next video I will give you some more examples. Okay.